Repairing flat flex cables can be tricky. In this video I'll show you 3 ways in which we can repair a flat flex cable. We can bypass the broken connection on the cable, we can cut the cable down, or we can then replace the cable. We could just jump to attempt number 3, which is what I would do in most cases. But you may not have this option. We will look at 2 other options first. In our first attempt, we will try to bypass the break in the flat flex cable. When attempting this type of repair, we need to take into consideration the temperature of our solder and soldering iron, and generally try to use low temperature solder where possible. We need to also ensure that the traces that we expose are clean. First I would tape down the flat flex down to a solid surface. In this situation I'm going to tape the flat flex to the anti-static mat on the bench. Just to be 100% sure, I will check the continuity of each of the connections to determine what traces need to be repaired. Once this is done, then I'll start the process of scraping off the covering for the traces to be repaired. I will use the edge of a sharp blade to gently expose the copper trace on the flat flex cable. Once we've exposed the copper trace, then apply a little solder flux and a little solder to pre-tin the connection. We then repeat these steps on both sides of the break of the flat flex cable. I use some wire wrapping cable to make the links to bridge both sides of the connection. I take care not to leave the soldering iron too long on each side of the trace, as the hot iron can very quickly melt and destroy the flat flex cable. Once you've completed the work, you can check the continuity to ensure the connections are now correct. You're now ready to test the display. In my case, this did work. Place some Kapton tape on the top of the wire links on the repair surface to hold the links in place on the flat flex cable. This is to provide some additional support, but I still want to show you 2 other options for repairing flat flex cables. In this attempt, we will cut the flat flex cable after the break. In some cases, the flat flex cable will be longer than is actually needed. Like the previous attempt, we tape the flat flex down to the anti-static mat on the bench to give it support. We expose the copper trace using the edge of a sharp knife. We then tin the exposed copper trace with some solder, and then we wash the cable with some cleaning alcohol such as IPA. When we test the LCD display back in the computer, we can see we get the same results as the previous attempt. Next, we'll show you how to replace the cable on the LCD display with a new one. When sourcing a replacement flat flex cable, you need to ensure the pitch of the cable matches that of the LCD display and the connector in the main PCB. For this particular module, it uses a cable that has a 1.25mm pitch. I was able to source the correct cable from Radionics, and it only took a few days for delivery. Upon getting the cable, the first thing I checked was to make sure that the pitch was correct by testing it on the main PCB. I also checked the pitch on the new cable against the LCD display, just to be 100%. Now we start the process of removing the old cable from the display module. As there is some epoxy resin that is used to hold the old cable in place, I used a sharp knife to gently break up the epoxy so it is easier to remove the old cable. Once the epoxy was removed, then use the heat from the soldering iron to gently release the old cable from the LCD module from one side. When the old cable was fully removed, I applied some flux and some desoldering wick to remove the old solder from the connection on the LCD module. Then wash down the connection with some IPA. I went over the connection a few times to make sure it was clean and there was no corrosion between the traces. The next step was the preparation of the new flat flex cable. I taped the cable down to the bench using some Kapton tape, making a general solder mask. I then added some flux to the contacts and pre-tinned the contacts using solder, using a wiping motion to ensure the contacts had a fresh layer of solder on them. Once this was done, I then washed the connection again in IPA and made sure it was 100% clean before moving to the next step. Using a piece of Kapton tape, I positioned the new cable on the connection on the LCD module, making sure that all of the connections lined up correctly. I made sure that a small portion of the copper contact on the LCD module was exposed, as this is where I'll be applying the soldering iron to heat up the connection later on. I applied a soldering iron to the portion of the first connection that exposed, while applying some pressure from tweezers above the connection. The heat from the pad is strong enough to melt the solder on both the LCD connector and the solder on the flat flex cable, causing a connection to be made. It's important you take your time here and don't rush to work. You may need to add a little solder to the connection to help it along. Just remember to keep the heat to a minimum on the flat flex cable. Once all the connections are made, wait for the cable to cool down and then wash it in IPA. Finally, we can now test connectivity from one end of the new cable to the LCD module. Once we have verified we have all our connections, we can now connect the LCD module back into the main board of the HX-20 and perform a test. As you can see, when we power on the HX-20, we're now seeing information on the LCD module. This lets us know that we now have connectivity from the main board to the LCD module, and we did in fact have a problem with our cable. We're now one step closer to getting the HX-20 up and running. In the next video, we will look at the LCD DC to DC converter that's located on the main board, as the LCD display is very dim, even when the contrast control is up full.